Hello students, in this video we are going to solve question number 4. And what is the question number 4? That depends upon Lenz's law. And there are few examples and I will give you some more questions so that you are ready for the exam also. So we need to understand what is Lenz's law. Lenz's law, as per the Lenz's law, the direction of induced current is such that it opposes the change in magnetic flux responsible for its production. Do you understand anything? No? Very good. Now I will explain you one by one what you need to understand. Guys, what is the situation? We know the word called induced current. Induced current. First of all, you need to understand how it produces. What is the procedure of its production? What is the procedure of its production? The step number 1, we have a word called flux, which is BA cosine theta. Yes or no? Second step, if I told you V induced, which is equals to negative d phi over dt. What is the significance of this negative? It means this gives you, what it gives you? It gives you induced voltage. Yes or no? Which gives you induced current. Till here clear? Induced voltage and induced current. But what is the significance of this negative? The significance is it always oppose. Always oppose. Okay, you need to understand what is the meaning of always oppose. Let's say case 1. Simple case. What you need to understand. Let's say, can I say V induced is directly proportional to negative? Yes or no? Negative d phi over dt. Okay, what you need to understand here, there are the two parts, V, and let's say there is a result x. There is something called x. So if x is 10, then what should be the value of V? Negative 10. Yes or no? As per this rule. Clear? Sure? You understand? Okay. Now what you need to understand. Let's say x is increasing. So the value is 20. So what should be the value of V? It should be negative 20. Yes or no? In opposite direction. In opposite direction. So can I say when x increase, then V decrease? Yes or no? From negative 10 to negative 20, it means it's decreasing. And from 10 to 20, it means it is increasing. Clear, guys? Case number 1. Okay, now this is a case of decrease. Let's say x is your 10, V is your negative 10. Fine. Okay, now x is your 4. X is your 4. What does it mean? Can I say this process is x is decreasing? Yes or no? Declining? Fine. So what should be the value of V? Can I say V is negative 4? Which is bigger, negative 10 or negative 4? Negative 4 is bigger than negative 10. Yes or no? Can I say V is increasing? Clear? It means it is in opposite directions. It is in opposite direction. Do you understand this thing? Whenever the factor of x or the magnetic field or the magnetic flux, whatever you can say, this x is trying to increase, then the voltage will decline. But whenever x is reducing or decreasing, then the voltage factor is increase. So do you understand now that it will always oppose? That's why this word always oppose. Clear, guys? Okay. Now one by one we will learn all these things. Let's say case number 1. I1 is increasing, I2 is declining. This much you already understand. I1 is your original current, I2 is your induced current. Let's say I1 is reducing, then I2 will be increasing. Fine? Okay. I will explain these cases to you. But before that, we need to understand some basics, some understanding, so that it will be convenient for you to solve the numericals. Okay? Now guys, I will give you a shortcut to solve these kind of questions. How to find out, or shortcut to find direction of Lenz's law, or direction of current, induced current as per Lenz's law. Okay guys, first thing, simple logic, scan. The word is scan. What is the meaning of this word and what is the logic of this word? S stands for south, C for clockwise, A for anti clockwise, and N is for your north. Okay. Second is your point of observation. That where the person is standing. From where means from where we are looking the question. From where we are observing. Okay. Now just see everything. Let's say there is case number 1. You will understand then everything. Case 1. Let's say this is your magnet. This is south, this is north. Okay. In case of magnet, we know one basic thing. What is the basic part? This is magnet. This is south, this is north. And how magnetic line of forces moves? Like this. North, out, south, in. And then they make a curve. Yes or no? North, out, south, in. Okay, this much you can remember. Okay, let's move to the question. Let's say there is a circuit and this north is going towards it. Okay, now you need to understand few things. First thing, let's say part A. This is your observer who is observing all these things, and this is the magnet. Here is south and here is north. What is the direction of magnetic field? This, yes or no? Okay, and this is your circuit. Now my question is, north is going towards means here the magnetic field B is increasing, yes or no? Trying to understand. Flux is BA cosine theta. It means flux is increasing. So what is V? V induced is minus, or make it equal so that you can understand, equal negative d phi over dt. What does it mean? If your phi is increasing, V will decline. Yes or no? Okay, it means decline means it will oppose. It will oppose means here you will get the north, so here also you will get the north. So that north and north can repel each other. Is it fine? Clear? Okay, then what should be the direction? Now there is a use of the word called scan. I told you whenever you see N, north, whenever you see the word north, then the direction is anti-clockwise. Whenever you see the word south, you will get the clockwise. So what should be the direction here? Yes. What you observe? North. So it should be anti-clockwise. So it should be anti-clockwise. Yes or no? Do you understand this case? Okay. We will take 2-3 more cases so that it will be convenient for you to solve all these type of questions. Okay. Now take another question. Question number B. Let's say your observer is here. Then we can change the direction also. Let's say person is moving like this and south north. Okay, no, this example I already taken, so change it and let's say north and south. Okay, and let's say the person is trying to move here. Okay, south is going, yes or no? Okay, if south is going towards, then what will happen? It will increase or decrease. Just think and tell me what will happen here. See guys, if south is moving, and you need to understand one thing, point wise point, south moving towards, okay, but with which intensity? Increasing. I'll take the another question with the decreasing also, huh? I'll take one more question here, the same question, but let's say here is your north, here is your south, and the same circuit, and I will say flux is decreasing. Here flux is increasing. Increasing means this will oppose, yes or no? Okay, if oppose, there is south, here should be south. It will oppose. But in case number 2, let's say flux is decreasing, then what will happen? V induced increase. Increase means in the same direction. Same direction means attract. It will attract him. So attract means south, here should be the north. Okay, now just apply the scan, SCAN. Okay, you have N, so the result should be anti-clockwise. Yes. Okay, apply the scan here. So here is south, so it should be clockwise. Do you understand? So what are the major things you need to focus? Again, I will write it for you, major points. Major points, what you need to understand. See, first, current or magnetic field. See, they will give you only two things. Magnetic field. Okay, you need to check increase or decrease. Clear? If it increase, then you will get opposite result. Oppose. Okay, and if decrease, it will try to help you. So here you will get attraction, and here you will get repulsion. Yes or no? Clear? This is the first point. What should be the second point? Scan. SCAN. Just check SCAN, and whatever is applicable, apply this. SCAN. Clear? Okay, the third step, what you need to focus. Okay, I will change the color. Third is called point of observation. Point of observation. Okay, take the same question and I will change the okay, one step go back, and I will just remove this point of observation and I will write something here so that it will not move. Okay, next page. Okay, take one more example so that it should be clear for you. Point of observation. Let's say 4 examples. 1, south, north, and this is the picture. Take another example so that all the 4 examples will be clear to you. South, north, and this is the observation. North, south, observation. North, south, observation. Okay, right now just try to understand person is here. Okay, first solve the question. Okay, north is increasing. Okay, I'll write flux is increasing. So we understand this will decrease. Decrease means oppose. Yes or no? Sure? Okay, here flux is decreasing. it means V will increase. Increase means attraction. Yes or no? These basic things you should know. Here flux is increasing. So what will happen? V will decrease. Yes or no? So it will oppose. Okay, here let's say flux is decreasing. So your voltage is increase, and same direction it will attract. Clear? Okay guys, now after that we will solve the question. This is north, okay, going towards it, so it will oppose. Here should be the north. Okay, till here clear? Okay, north decreasing, so it will trying to attract south. Okay, this is increase, so it will decline. Decline means oppose. Oppose means south. Okay, here decrease, it will trying to attract him. Attract means who will attract? North. Guys, now there is a major mistake done by the students. Okay, I will remove this so that you can understand. This is a magnet, yes or no? So just make it a full magnet now. So what will you observe here? South, yes or no? Make it a full magnet so that it will be clear to you. So here should be the north. Make a full magnet. So here should be the north and here should be the south. Because now from which side you are observing? From the opposite side, from this side. Yes or no? Do you understand this part? Easy? Because there is a full magnet. Now because there is not only one, you can say, the pole. There are both the poles. Okay. Now south is there. So apply scan. So what should be the result here? It should be the clockwise. Yes or no? And what should be the result here? Anti-clockwise. Clear? South clock. If you observe from this position and if you observe from this side, the result is anti-clock. Clear? If you observe from here, so it should be clock, and if you observe from here, it should be anti-clock. If you are observing from this side, the result is anti-clock, and here the result is clock. Guys, clear now? Fine. Okay, now I'm going to take one question which they already asked during the exam. This one is something very, very interesting. Okay, they give you one direction and you need to observe. Okay, the major point what you need to understand, that how to identify the direction. Okay, the first thing what is given in the question, they will give you the increasing. You understand? Increasing. Increasing means the other side will oppose. Okay, wait. I will take this and I will explain in the another page in detail so that you are able to solve this question in a proper way during the exam. Okay, add one more page for you. Okay guys, now remove this. Okay, try to understand the first part. Case 1. Very easy, huh? First case, something is going like this. Do you understand? Okay, first try to understand this point out. What this trying to tell us? This is called north. Why north? Because I told you during a magnet, the line of forces are going out from north and going in from south. It means this is your north and this is your south. Yes or no? Clear? You understand what is the north, what is the south? Okay. So first direction, try to understand. Case 1. One is like this, another is like this. So this is your north and this is your north. Yes or no? Do you understand this point? Okay, so what they are trying to show us? They are trying to show us repulsion. If they are trying to show us repulsion with north, so what should be the direction as per scan? Tell me fast. So direction should be anti-clockwise. Yes or no? And what you need to observe? Always observe this case. Always observe this case. This gives you the direction. Clear guys? Now we will go for case number 1. 1 is finished. 2, 3, 4. Okay guys, now case number 2. Now solve it. Case 2. Very easy. One direction this side, another direction this side. Okay, what do you observe here? Tell me. What do you observe here? South. What do you observe here? South. And who will give you the direction? This south will give you the direction. South means just apply scan. Yes, yes, yes. So south will give you clockwise. Just check the direction. The direction is clockwise. Is it fine? You can see the direction. It is clockwise. Clear? Okay, case number 3. Solve it. Yes, what we have, one is like this, one is like this. So what we have here, north. What we have here, south. So south will give you clockwise. Yes or no? So this is the point of observation. Clear? In case number 4, very simple case. One is like this, one is like, second is like this. So what we need to observe, this is your south. What is this? This is your north. And north will give you anti-clock. Is it fine guys? Now you are able to solve such kind of questions. Easy. Okay. Now the next point is to solve the problem related to Lenz's law. Okay, this is very simple. You need to understand. See, we know this thing that we have the different type of forces. We have the magnetic field. Magnetic field produce electric field. And the change in electric field produce the magnetic field. So keep both the forces same. Okay. So in terms of magnetic field, as we know, magnetic field, which gives us QVB sine of theta. Okay, remove the sine theta because right now we are not looking for the angle. And FE due to electric field, QE. This is from your term 1. Okay, make them equal. So QVB is equals to QE. Yes or no? Can I cancel the Q? Simple. And can I say what is the value of electric field? Electric field is V. Electric field is V times B. Clear? Okay. We have another formula. E times V induced divided by L. This is also from your term 1. Okay guys, I'll tell you something, that if you don't remember these formula, leave them. We are not going to use them. No use. You have to remember this equation directly. Either that V induced is equals to negative d phi over dt, or you can remember directly V induced is BLV. This is your simple formula. Clear? If you remember this, you can solve the questions. B is your magnetic field, L is your length, and V is your velocity. Clear? Okay. Okay. Now, time for the numericals. And in this, we have few numericals. And I just want to inform you that you understand this equation. E is equals to V induced divided by L, or VB. This is the equation we are going to use again and again. V induced is V induced, you can use LVB or BLV, and if there is an angle, sine of theta. If you use the integration, you will get B times of pi r square divided by T. Okay, but this we can solve, and I can show you how to solve these types of numerical. Fine. Okay, now on this page we have two numericals. I already separated them one by one. Let's say solve it. A metal bar is moving with a constant velocity. Okay, velocity is this side, this is your velocity, through a uniform magnetic field pointing into the page. Into the page means, okay, V is positive x-axis, into the page, magnetic field. Can I say that is along the negative z-axis? Okay, as shown in the figure. Which of the following most accurately represent the charge distribution? Charge distribution means we need to find the force. We need to find the force, because I'll show you why I'm telling you in case of charge distribution you need to find the force on the surface of the metal bar. Okay, as we know, we have a simple formula. F is equals to Q V B sine of theta, or can I say q v cross b? Yes or no? Find the direction of force. F is equals to q, I don't know, but I am considering, because force, whenever the result is force, is applicable on positive charge of the positive charge, you can say. So v cross b. Okay, put their values, put their direction. So F is equals to, what is V here? Positive X multiply. What is the value of negative Z? Okay, take out negative outside. So X cross Z. X cross Z is negative Y. Negative, you can say the Y. So what is the total result? Plus Y. What is the force? Plus Y direction. It means, let's say this is the wire. So force is applicable like this. So what is the direction? What should be the upstairs? That should be positive. Here should be negative. Is it clear? Because force is applicable in the direction of positive charge. Force is applicable in the direction of positive q. Clear, guys? Fine. So what should be the answer? Yes, we have distribution C. Distribution C is the correct answer. Clear? Now question number 3, example 3 in 9.3. In 1996, the space shuttle Columbia deployed a tethered satellite on a wire out of a distance of 20 kilometers. So L is equals to 20 kilometers. The wire was oriented perpendicular. Theta is equals to 90 degree to the Earth's magnetic field at that point, and the magnitude of the field was B is equals to 5.1 times 10 raised to power negative 5 Tesla. Columbia was traveled at a speed, okay, velocity is 7.6 kilometer per second. What was the potential difference? Okay, we induced, we are looking for. Okay, guys, so what we have the velocity, we have the magnetic field, we have the theta, we have the length. Okay, now just solve all these things. So we have V induced is equals to BLV sine of theta. Place the value. What is the B? 5.1 times 10 raised to power negative 5. Okay, length 20 kilometers. Okay, just convert this. So it will become 20 multiplied 10 raised to power 3 meter. Okay, put it here. 20 times 10 raised to power 3. Okay, velocity kilometer per second. Okay, convert it. 7.6 kilometer means 10 raised to power 3 meter per second. So place it here. 7.6 times 10 raised to power 3 sine 90. That is equals to 1. Okay, solve it fast, fast, fast. Okay, you will get 7.8 times 10 raised to power 3 volt. That is your V induced. Clear? Easy. Okay, and this type of questions you will get in your exams also. Okay, now move to the next question. So what is your next question? Guys, just read it carefully, fast, So this is very interesting one. A conducting rod is pulled. Okay, let me go down. I will explain there, Yes. A conducting rod is pulled horizontally. Okay. If pulled horizontally, it means there can be a change in length by a constant force of magnitude. Force is given. Force is 5 Newton. Okay. Along a set of conducting rails separated by a distance A. A is given, which is your A is 0.5 meter. Okay. The two rails are connected and no friction across between the rod and the rails. Okay. A uniform magnetic field. Uniform magnetic field value is B is equals to 0.5 Tesla is directed into the page. So the direction is negative z axis. Okay. The rod moves at a constant speed. Velocity is given 5 meter per second. What is the magnitude of induced potential difference? Okay, V induced we are looking for, and what is the formula? BLV sine of theta. Okay, in the loop formed by connected rail and the moving rod. Okay guys, so how will you solve this? See, we have A, it means we have the length. Okay, in the question it is given now, this is your length from this point to this point. This is your length of the rod. Okay, B is given, V is given, and theta there is no need. I told you if it is given then we need to use it, even it is 90 degree. So B is your 0.5. Okay, what is the length? 0.5. And what is the velocity? 5. Can you solve them? Each of them? Okay, you will get 1.25 volt. Easy. That is your V induced. Fine. Okay guys, now just move to the next question. Concept check 9.5. A wire loop is placed in a uniform magnetic field. Okay, we have something over a period of 2 seconds. Over a period of 2 seconds. Time is given 2 seconds. The loop is shrunk. Okay, it means, guys, just try to understand. Area is changing. Yes or no? Okay, it means V induced is equals to negative d phi over dt, which is equals to negative b cos of theta dA by dt, because it is shrinking. Okay, which statement about the induced potential difference? Induced potential difference is correct. Okay, there will be some induced potential difference. Yes, it's correct. There will be no induced potential difference because the loop changes size along the one axis and not the other. No, it's wrong. There will be no induced potential difference because loop is not closed. Wrong. Okay, there will be no induced potential difference because loop is shrinking. No. So guys, your correct answer is A. A is your correct answer. Clear? Till here clear guys? Okay, now time to move to the next question. And now the question which we are going to solve, example, solved problem 9.1. This is something very, very, very dangerous one. And I just want to tell you, it's very, very important for your exam point of view. You need to understand, and you need to at least solve this question 2 to 3 times. And let's say if you are able to solve this. A conducting rod with length. Okay, length is given 8.17 centimeter, which is equals to 8.17 times 10 raised to power negative 2 meter. Okay, rotates. This is the keyword, And in all the questions, whenever you get such kind of questions, you need to keep in your mind. And even in the question, if you observe something, this from this point to this point, this is length L. Yes or no? Can I say this is equals to radius also? If you understand this point, the question will be little bit easier. So can I say length is equals to radius? Fine. Okay. So can I say V induced, we have formula BLV. Yes or no? Can I say this formula as BRV? So that we can understand all the things. Okay, come back to the question. A conducting rod with length, okay, length is given, fine, rotates, this is your keyword, around one of its end in a uniform magnetic field that has a magnitude of, okay, magnetic field is given, B is 1.53 Tesla and is directed parallel to the rotation axis of the rod. Okay, see, parallel with the, okay, you can say alpha is parallel 0 degree. If you want to find theta, 90 minus alpha, which is 90 minus 0, which is equals to 90 degree. And what is the real formula? BLV sine of theta, and theta is 90 degree. Can I say sine 90 is equals to 1? Yes or no? Okay. The other end of the rod slides on a frictionless conducting ring. Okay. The rod makes 6 revolutions per second. What is the meaning of this thing? You need to focus. I said 6 revolution per second. It means frequency is given. Yes or no? Or you can say omega, which is equals to 2 pi divided by t, or 2 pi f. Fine. Okay. Now, a resistance or the resistor 1.3 R is equals to 1.63 milli ohm. It means 1.63 times 10 raised to power negative 3 ohm. Okay, is connected between the rotating rod and the conducting ring. Okay, there is a ring and it's keep on moving. What is the power dissipated? We need to find the power. We have I square R or V square over R. These are the two formulas due to magnetic induction. Clear, guys? Still here, understand? Okay, now the major thing what we need to find out. We are looking for power. Yes or no? Okay, what is the formula? V square over R. Okay, R we know. V induced is BLV. Where length L is changing. From where? It starts from 0 to capital L. Here, just check how it is changing. You can just check from here it starts, and this is the complete circuit. So it's keep on moving. Fine. Okay, and it is also making the 6 revolutions per second. Okay, guys, now time to understand and to solve this question very, very carefully. Now, just focus on this point. The step number 1. Step 1. To find the power, we need V induced. Can I say V induced is BLV? Okay, this is the full value. If length is changing, can I say delta V induced is equals to BVDL? Yes or no? Do you understand? We have to solve full value. Okay, so can I say to find V, integration V induced, which is equals to integration BVDL, and the limit is 0 to L? Yes or no? You understand this thing? Or you can take in terms of R, in terms of L also. Okay, I just need to add a page here so that I can explain you in a proper way. Add a page. Okay, now just remove this. Till here, do you understand? Okay, now place the value. So here you get V induced, which is equals to B. Okay, we know what is V. Okay, what is velocity? Tell me, what should be the formula of velocity? I can say 2 pi R divided by T. Yes or no? 2 pi R divided by T. Okay, can I say V is equals to, because in this case R is equals to L, 2 pi L divided by T. Fine. Okay, place it here. So B times 2 pi L divided by T dl, integration 0 to L. Okay, now just solve this. So V induced equals to B times 2 pi divided by T. Take it out. Integration L dl 0 to L. Okay, solve this. Here I will solve it for you. Integration of x dx 0 to x. So what is the value? X square divided by 2. Clear? So here what will you get? B times 2 pi divided by t. Here you will get L square divided by 2. 2 and 2 cancel. 2 and 2 cancel. So what is your formula? V induced is equals to B times pi L square divided by t. Or we can use the same formula, B times pi R square divided by t. Do you understand? Sure. Okay. Till here we get the value of V. Okay, now solve the power. So we have the formula for power. Power is equals to V square over R. Okay, V square is B pi L square divided by T whole square multiply 1 over R. Solve it. B square pi square L power 4 divided by T square multiply 1 over R. Clear, guys? Okay, place the value. Now, what is the value of B? You have 1.53 Tesla square. Pi is 3.14 square. Multiply. What is the length you have? Yes, length is given. Okay. 8.17 times 10 raised to 1 negative 2. Okay. Power 4. Divide by T square. What is the time given? What is the time here? Just you need to think, he takes 6 revolution. So 1 over 6, he said in 1 second. So it should be 1 by 6. I said, first you need to understand, I said in you can say in 1 second you finish 6 rounds. Yes or no? In 1 second you finish 6 rounds. In 1 round, how much time you will take? 1 round is equals to 1 over 6 second. Yes or no? Do you understand? So what is the time? 1 over 6 square. And what is the resistance? Okay, 1.63 times 10 raised to power negative 3. Okay, solve it. So you will get, what is the value of power? 22.73 watt. Clear? Or you can just remember this equation directly. That's why I put this equation in the notes, that whenever there is a change in length. Okay, I'll give you a shortcut, shortcut to solve this question. Direct shortcut. In case you need to solve it. So in case whenever length is changing, whenever length is changing and L should be equals to radius. In that case, you can use V induced directly. You can use, what is the formula you can use? Just tell me. B pi L square divided by T. This is the direct formula. Instead of solving all these things, you can directly solve. Then P is equals to V square divided by R. So just make a square of this value divided by R. You will get the answer. Easy. Fine. Okay. Now one more question. Okay, suppose the length of the rotating rod in problem 9.1 is increased by a factor of 2. Increased by a factor of 2. Okay, now we have, okay, by what factor does the power dissipated in the resistor change? Guys, we have the power 1. Just check the formula. Power 1. See, we have formula V square over R. So can I say B pi L1 square divided by T square, B square pi square L raised to power 4 multiply R1. Okay, this is your power 1. Power 2, what he said? L is increased by a factor of 2. It will become 2L. It will become 2L. Yes or no? I will write it here for you. Okay, so your L2 is equals to 2 times of L1. Place in the formula. Power, what happened? Just give me a second. Okay, power 2 equals to B square pi square 2L1 power 4 divided by T square R. Okay, till here do you understand? Yes or no? Okay, and remove this one because resistance is same, all other factors are same, only there is a change in the length or the radius. We need to find the change. So P1 divided by P2. Can I say all other factors are same? So can I say L1 raised to power 4 divided by 2 times of L1 raised to power 4, which is equals to L raised to power 4 divided by 16 times of L raised to power 4. So what is the ratio? P1 divided by P2 is equals to 1 over 16. Is it fine? So can I say the change is P2 is equals to 16 times of P1. Fine, guys. So till here we covered our Lange's law. So if you have any doubt, just you can ask me directly, and just keep on practicing so that everything will be clear. Okay, guys. So I will meet you in the next video. Till then, take care. Bye.